Okay, so we're going to talk about one of my favorite topics, which is elasticity. Elasticity is the response of one economic phenomenon to a change in another. And elasticity allows you actually to measure that response. So elasticity is actually answering the question, how much? And so the most basic example that we're going to use and we're going to talk the most about is the price elasticity of demand. We know that demand curves slope downward, and so that we know that if a price falls, the quantity demanded is going to increase, or if the price rises, the quantity demanded is going to decrease. And what elasticity allows us to do is answer the question, by how much? And we're concerned about putting it into percentage terms, although elasticity, as I'll show you in a moment, is not a measure in terms of percentage. It's just actually just a number that isn't in any kind of unit at all. It's just elasticity. So the elasticity in terms of the price elasticity of demand is the percent change in quantity over the percent change in price. So if the price changes by a certain percent, the quantity is going to change by a certain percent, and we're going to divide the quantity by the percent change in quantity by the percent change in price, and we're going to end up with the elasticity. And the only real twist in this class is that in calculating percent changes, we're going to be using the midpoint method. And the reason we're going to use the midpoint method is that we want the elasticity between this point and this point to be the same, whether we're moving in this direction along the demand curve or in that direction along the demand curve. While a traditional method of calculating percent changes would actually give you different answers depending upon which direction you're going. Think, for example, if you had 100 and you subtracted 10% from that, you'd end up with 90. And if you took that 90 and added 10% to that, you'd end up with 99. Well, that really bothers me in terms of elasticity, that if you add 10 or subtract 10% and then add 10%, you don't get back to where you were before. By using the midpoint method, you would. So the midpoint method says that to calculate a percent change of, say, the quantity, we'll take the second quantity, subtract the first quantity, and then we'll divide that by the midpoint of the two quantities, which of course would be the first quantity plus the second quantity divided by 2. And so that's the percent change in quantity, which is the numerator of our elasticity. And then the denominator is going to be the second price minus the first price, which is the change in price, obviously, over the midpoint, which would be the average of the first price and the second price. And so this is going to end up being the percent change in price. Now realize on a demand curve that these are going to be going in opposite directions. If the price falls, the quantity is going to go up. If the price goes up, the quantity is going to go down. And so this ratio will end up being a negative number. And since it's always going to be a negative number, and negative numbers can be irritating to work with, we're going to just take the absolute value. So we're just going to put the absolute value sign there, so by the time we get over here, we're already into positive territory, and so then we're going to end up with an elasticity that is greater than or equal to 0. That's true of the price elasticity of demand, which is actually the only elasticity that we're likely to take the absolute value of. For other elasticities, the sign actually matters, and some of them are going to be positive anyway. But so for price elasticity of demand, we'll just think of it in terms of absolute value. So it'll be a number between 0 and infinity. Let's do an example. Let's think of Daisy's Ice Cream Store in Coventry, Connecticut, my hometown. And let's imagine that Daisy is selling ice cream cones for $3.25. And there's some demand curve that the store faces. And at $3.25, the store is able to sell 75 ice cream cones every day. And then they decide they think they'd like to sell more and see if they can lower the price and sell more. Well, we know if they lower the price, they're going to sell more. But the question is, how much? And so let's say they lower the price to $2.75. And after they lowered the price for $2.75 and didn't necessarily draw this to scale, they are selling 125 ice cream cones a day. So let's calculate the elasticity of a price drop from $3.25 to $2.75, changing the quantity demanded from 75 to 125. So the percent change in quantity is going to be 125 minus 75 over the midpoint, which is the average of 125 and 75, which I think we can just do, well, let's just do it. 75 plus 125 divided by 2, and this is going to end up being 50, and this is going to end up being 100, and that's going to be 1/2. So it's a 50% is the percent change in quantity demanded. And the percent change in price, we went from 325 to 275. So notice this is the one that would be negative because the price fell, and that'll be over the average of 270. Oh, Q1 plus Q2. We'll do it this way. 325 plus 275 divided by 2, and so this is going to end up being 50 cents. That was the change in the price, and this is going to end up being $3. And so this is going to end up being 1/6, so or 0.166666. And so if we have 1/2 divided by 1/6, that's going to equal 6 over 2, which is going to equal 3. So we have an elasticity of 3. That's actually a very strong. That's actually a very strong response. As you may remember, we discussed in class, the key number for elasticity is actually, even though it goes from all the way from 0 to infinity, the key number is 1. If the elasticity is less than 1, we say that the response is inelastic, and if the elasticity is greater than 1, we call that response elastic, and if the elasticity equals 1, we call it unit elastic. And so what we said was that if the elasticity is greater than 3, if the elasticity is greater than 1, and clearly 3 is greater than 1, if elasticity is greater than 1, the quantity effect of a price change should be stronger than the price effect. Well, we know that the price went down, which means less money for Daisy, but they sold more, which means more money for Daisy, and the selling more, that quantity effect, should outweigh the price effect if the elasticity is greater than 1. So let's see if that really happened. So this is the quantity effect. That's the change in the number of cones that were sold, and we know this is 50, right? This from 75 to is 50, times the amount we were able to sell these cones for, which is $2.75. And so that's the quantity effect, and that equaled $137.50. That's 50 more cones at $2.75 each. And then this is the price effect. I'll put that in red because this is now money that Daisy isn't getting anymore. And the price effect is that, remember those 75 people that were buying cones before, back when it was $3.25? Well, they're still buying the cones, but now they're only paying $2.75. So they're paying 50 cents less. So this is money that Daisy isn't getting. So that's, and there were 75 of those, so it's 75 times the 50 cents that they're no longer paying because the prices come down. And so this is going to equal $37.50. Well, it's probably pretty obvious that $137.50 is a bigger number than $37.50. So the quantity effect was stronger than the price effect, which is what exactly should happen if the elasticity is greater than 1. And as I said, 3 is greater than 1. And if you wanted to do a check, you could see that the 75 times the 325, this area is $243.75, and our new area our price times our quantity, the $2.75 times 125 is $343.75. $343.75 is greater than $243.75. Therefore, the quantity effect was larger than the price effect, and that suggests that the elasticity was greater than 1. And when we calculated the elasticity, we saw that in fact it was 3, which is greater than 1. All right, so hopefully you got all of that. And so, let's just think of a few things that affect elasticity. Elasticity is affected by the availability of close substitutes. If there are more substitutes available, your response is going to be more elastic. If they raise the price of one thing and there are substitutes available, you can go buy that other thing. Some people will, so there'll be a response in terms of that. And if you lower the price of your item, and there are a lot of close substitutes and some people buying them, well, you have a chance to attract those customers. If it's a necessity or a luxury, will affect the elasticity. The necessities have a smaller elasticity. There's less of a response if it's a necessity. A luxury is going to have a greater response to change in price. And the share of your income. If it takes a great share of your income and say the price goes up by 5%, well, that's going to have a big impact on your personal budget. You're going to cut back more than if it's something really trivial like shoelaces or something. A 50% increase or even 100% increase in shoelaces may not change the number of shoelaces you buy even a little bit. So it may have a very small or even zero elasticity. The shape of the demand curve is a clue to whether the item is elastic or not. And we can think about the thing I talked about in class, which was that the soda at the stadium at Rensselaer Field, when you go to a football game, is actually very expensive. And my housemate suggested that, well, perhaps they should lower the price, they'd sell more. And because there's no availability of substitutes, because they do not allow other beverages into Rensselaer Field, you have to buy them from the official contestant stand. They actually check you as you're coming in and don't allow any other beverages into the stadium. So they are trying to reduce the elasticity and make sure that all the thirsty fans want to buy. And so if it's inelastic, the demand curve is going to look more vertical. And so if the soda is at $7 a cup, and we sold, say, 1,000 cups of soda during halftime, if you lower the price to, say, $6.50, you will sell more. But notice how that quantity effect is just little tiny, right? You'll have this big price effect, and then this tiny little quantity effect, and so you're actually going to lose money if you lower the price and you are in an inelastic situation. And having a more vertical-ish demand curve is inelastic. And then, of course, the more horizontal demand curve would be elastic. So if you had an item, say, a luxury that had a lot of close substitutes, and so you sold this particular quantity and at this particular price, and then you decided to lower the price, you would just be able to pick up a whole lot more people. You have this very large quantity effect if it's a more horizontal line. So the action is along this x-axis here. How big is this quantity effect when we change the price? That is the question that elasticity of demand is trying to answer.